Dear Professor Hiroshi Amano, Honghai President Yang Liu, honorable delegates, ladies and gentlemen, good morning. I hope all of you and the families are going well and staying safe. Welcome to the next forum, Compound Semiconductor in Electrical Vehicle. On behalf of the co-organizer Honghai Research Institute and the SEMI Taiwan, I'm very pleased to welcome an extremely distinguished caliber of speakers, as well as our partners in industry, in the government, and the academia. We have invited more than 10 experts to share their thoughts on their areas of expertise, and I know for certain all of us will benefit greatly from this event. Taiwan has been one of the most important hotspots in the global semiconductor industry, not only with a solid supply chain, but also with the sophisticated domain-specific supply divisions, and created the very unique horizontally linked wafer, packaging, and testing foundry industry. Taiwan's technological and production innovations in semiconductors has reached the cutting edge of the world. As we all know, Taiwan has made a great advancement in integrated silicon technologies and continues to maintain and strengthening the technology leadership in this specific domain. While silicon-based devices has reached its performance limits in high power handling and high frequency gain, compound semiconductors have emerged as more promising candidates in some of the most challenging applications, especially for those used for electrical vehicles. Undoubtedly, the electrical vehicle is driving technological innovations in power devices made by wide-band semiconductors, such as gallium nitride and silicon carbide. Today, Professor Amano will address us on how to face such challenges with gallium nitride. And then many prestigious companies, including Infineon, ST Microelectronics, Gallium Nitride System, IQE, Applied Materials, TSMC, Skyworks Solutions, Win Semiconductors, and Foxconn will share us with their R&D directions and strategies. In addition, professors from Hong Kong UST, University of Science and Technology, National Taiwan University, National Yangming Jiaotong University, National Cheng-Kung University, and the ITRI will also share their recent advances in integrating compound semiconductors. Our joint efforts in fostering the innovation through this platform and the constant and the substantive exchanges between industry, government, and academia will lead us on the way to a fast-growing and fruitful future. Thank you to Honghai Research Institute and the SEMI Taiwan for arranging this forum. And thank you all for joining us today for this exciting event. And again, I like to highlight, acting together, we go far. Thank you.
Honorable guests, ladies and gentlemen, welcome to this year's NExT Forum, which coupled with the Semiconductor Taiwan. In this year's NExT Forum, we are going to talk about the compound semiconductor with applications in electrical vehicles. The third generation semiconductor materials of gallium nitride and silicon carbide being to be the group of wide bandgap semiconductors are increasingly being viewed as an alternative to silicon for 5G and EV applications. This forum gathered prestigious speakers and industries leaders together to share their thoughts and their views in this particular area. This virtual meeting will address key topics in the field of gallium nitride and silicon carbide, with its main focus on EV applications, which will inspire leaders from the industry and encourage all the participants to a promising future. Most noteworthy for this year's NExT Forum, we have keynote speakers by Nobel laureate, essentially the laureate address. Professor Amano shared the Nobel Prize in Physics in 2014 with Professor Isamu Akasaki and Professor Shuji Nakamura for the invention of efficient blue light LED, which has enabled bright and energy-saving white light sources. I still remember 15 years ago when we were actually worldwide leaders were competing for blue light LEDs. That time, blue light LED has the lowest efficiencies in the three color LEDs, meaning red and green. When they announced their inventions, suddenly we found out blue LED has the highest efficiency, which is the fundamental reason we have high efficient white light LED source. So their invention, 2014's Nobel Prize, has honored this particular development. In fact, they changed the world once. Now, Professor Amano wants to change the world again by developing deep UV LEDs. So his recent efforts is developing and for the fabrication of high efficiency power semiconductor development and new energy saving devices at Nagoya University. Aluminum gallium nitride based deep UV LEDs on substrate are useful for the efficient and long life devices for sterilizing and purifications of air and water. For example, disinfect COVID-19. Application of DUV LEDs, including sterilizing for sanitization facilities, raisins and curing of inks in large printers, detecting forged banknotes, photolithographies for manufacturing semiconductor devices, and treating skin diseases, which is today called dermatologist. In his presentation, he will talk about his development and activities on the gallium nitride device fabrications. So we essentially looking into his talk and believe he will change the world again. Other speakers from TSMC, Foxconn Shop, Win Semiconductors, ST Micro, Applied Materials, Global Wafers, Gallium Nitride Systems, IQE, HKUST, the NYCU, NCU, E3, and more. We believe this year's forum will bring to us all the latest development of the wide bandgap material, gallium nitride, and silicon carbide, with emphasis on applications in the EV vehicles. We believe this year's forum will bring many interesting insights to all the audiences. I hope you all enjoy this particular forum. Thank you very much, and remain healthy for the COVID-19 period. Thank you very much, and we look forward to have next year's NExT Forum in the face-to-face forum instead of the virtual forum. Thank you very much. And I hope you enjoyed it all. Thank you.
Ladies and gentlemen, Yang Liu, Chairman of Hon Hai Technology Group, Chairman of E3 CKD, Semi-Taiwan President Terry Chow. It's my pleasure to meet you all online, and thanks to Semi-Taiwan for inviting me to participate in NExT Forum, Compound Semiconductor in e-vehicle. Since 2016, the government has been taking the advantage of Taiwan's semiconductor capability to promote innovative application of the 5+2 Industry Innovation Plan. By doing so, we hope that the semiconductor industry can help share 6 core strategy industry develop better while expanding its presence in the global semiconductor industry. To attract more industry to continue investing in R&D and innovation, the government keeps working hard to create an innovation-friendly environment, embracing new ideas to be turned into new products and services. We believe some emerging industries like compound semiconductors will make Taiwan's semiconductor industry more competitive in the future. With the wide bandgap future, compound semiconductors can be used to develop high frequency and high power applications to better meet the increasing demand and the new opportunities for electric vehicles, 5G, 6G, low orbit satellite communications, and the new energy and defense technologies. The government is aware that it is our prime duty to cooperate with key industry players in EV, 5G, and the new energy by promoting global industrial alliances and interdisciplinary cooperation. The government aims to help the industry extend advantage from silicon semiconductors to compound semiconductors. At the invitation of Semi-Taiwan, I'm pleased to see so many of you from different sectors around the world sharing your valuable opinion and research findings. With many years of effort, Taiwan has excellent high-tech manufacturing capabilities that have helped us stay atop in the silicon semiconductor industry. While Taiwan can gain the forever advantage again in compound semiconductors, we could help the global semiconductor industries maintain the competitive advantage in the shared future. I'm truly honored to be part of this forum on behalf of IDB, Ministry of Economic Affairs. Hope I have given you a glimpse of policy and the plan of Taiwan's semiconductor industry. Wish all of you stay safe and healthy until we meet again. Thank you.
Dear Professor Amano, Professor Mao Zhong-Zhang, distinguished guests, ladies and gentlemen, good morning. First of all, on behalf of FOSCON, I would like to thank you for joining us today. This forum is organized by the Hon Hai Research Institute in Semi-Taiwan. The establishment of the Hon Hai Research Institute is an important step in supporting our 3+3 initiative. The threes referring to the 3 emerging industries: electric vehicles, digital health, and robotics, and 3 major core technologies: semiconductors, artificial intelligence, and next-generation communication. Hon Hai Research Institute holds a meeting every quarter to discuss the research fronts of a specific topic. Today, we are fortunate and honored to have so many distinguished speakers and outstanding representatives from respective industry and the government. It is an opportunity to highlight important issues in the field of compound semiconductors, mainly focusing on EV applications. As we may know, EV trends are paving the way for the third-generation semiconductors, such as gallium nitride and silicon carbide. These materials continue to drive innovation throughout EV charging design and the infrastructure. It is critical to take advantage of this momentum to open up new channels into the international marketplace. It is necessary to deepen the relationship among academia, industry, and government. I'm pleased to share our latest news about third-generation semiconductors. Last month, as a symbol of our long-term commitment to the semiconductor industry, we purchased a 6-inch wafer fab, facilities and manufacturing equipment included. It is an important milestone for Foxconn to be capable of manufacturing the third-generation semiconductors, particularly silicon carbide. In addition, we have promoted an open EV alliance, the NIH Consortium, for creating an open EV ecosystem. Currently, more than 1,800 firms worldwide have joined the alliance to facilitate innovation in the mobility industry. Last but not least, I would like to thank Professor Amano for his great vision and contribution to make this meaningful event possible. It is our belief that today's event will further strengthen the impact of compound semiconductors regarding EV development in the world. Thank you, Professor Amano, and all participants. I wish this event a great success and everyone here today a most rewarding and enjoyable foreign experience. Thank you.